Continuing on physical chemistry, physical chemistry, we're in chapter 9, section 7 now. We're going to talk about ideally dilute solutions. Now remember, we already said an ideal solution, this solution exists in the limit where the molecules of the different components resemble one another very closely, but without actually being identical. Now, an ideally dilute solution is something a little bit different. The solvent mole fraction approaches 1. In other words, it's almost pure solvent, and the amount of the solute present is very small. In other words, an ideally dilute solution is where there is just a teeny weeny bit of solute in a whole bunch of solvent. Now, this would not apply to electrolytes at all. We're only, molecules. Electrolytes can't be in an ideally dilute solution. We'll talk about why later on when we actually do electrolytes. Now in this nomenclature, we're going to use capital A to mean the solvent and lowercase I to mean the solute. So we're going to talk about the chemical potential, mu sub A. That's going to be mu sub A star. Remember, star means pure substance at whatever temperature and pressure, plus the gas constant R times the absolute temperature times the natural log of the mole fraction of the solvent A. And remember, since we're talking about an ideally dilute solution, the mole fraction of the substance A, the solvent, is roughly equal to 1. And then for the solute, subscript I, so chemical potential of the solute is equal to the chemical potential of the solvent I in its pure state at temperature and pressure, plus the gas constant R times absolute temperature times the natural log of the mole fraction of the solute. So this is for the solute in an ideally dilute solution. But remember, this mu sub I naught, this is a fictitious standard state. We'll talk about what that means in a little bit.